students, today in continuation with the application of dimensions, we'll discuss some applications and their examples. The first application is to check the dimensional correctness, of a given physical relation or equation. So this is the first application which we are going to discuss. And in dimension already we have discussed homogeneity. Homogeneity means that left and right dimensions are same. They follow the addition and subtraction for the same dimension. Now that means if the dimension of each term on both the sides are same, then they are correct. Now I am giving an example that if F is mb square by r. Now I think most of you know this is a centripetal force, but right now we are not going to be in the details of the description of this force, but we have to check it. What is the dimension of force? And all of you know it is mlt minus 2. How it has come mass into acceleration. And then if I put it here, the dimension of mass m, what is the dimension of velocity? Lt minus 1 square by what? R is L. Got it? So this is mb square by what? R. So if you solve it out, it becomes ml square t minus 2 by L. And then one L goes from here. So finally it is what? mlt minus 2. So we can say that the dimension of both sides are same. Okay, so we can say that this is the equation or the formula is dimensionally correct. So this is how we are going to. Another example is that if I give you that F is equal to 6 pi eta RB. Now this formula deliberately I have given here. This is the formula which will come in fluids, viscous force, viscosity. You have viscous fluids, there is a friction. But right now again I am saying that we are not going to get in the details of this, but we are going to check it. 6 pi is a constant, F is a force. So a force is again mlt minus 2. Now 6 pi is a constant. Eta, what is eta? Eta is coefficient of viscosity. And some of you may have gone through its dimension. I am going to write it. Its dimension is ml minus 1 t minus 1. Go through it. So if I put it here, ml minus 1 t minus 1, what is r? Radius. L, what is v? Velocity. Lt minus 1. So solve it out. It becomes m l minus 1, then this l, then this l, and then t minus 2. So simply it is mlt minus 2. Got it or not? What is r here? Radius. What is v? Velocity. It will be given there, but you have to memorize some dimension, like one of them is coefficient. So we know that again here what? LHS is equal to RHS, dimensionally correct. So in this way we can see that some physical relation are given here. So these are the two examples. One was for centripetal force and another is for what? Viscous force. In the same way we can check the consistency of equations. How? Say S equal to ut plus half at square. Now most of you know, I think this equation, S equal to ut plus half at square. So if I ask you what is S, then all of you know that it is L. U is initial velocity, LT minus 1, T is time. Got it? Half will have no dimension number. Then acceleration is LT minus 2. Then T square time is T. Okay, in this way you can write. So this is L. If you solve it out, T will go, T will cut, it will be again L. And here T minus 20 square, it will be L. So L is what? L plus L. So we can say dimensionally the relation is correct. The relation is correct because we have same dimensions. Similarly, can we check V square minus U square equal to 2AS? I think yes. We all know V is LT minus 1 square. It is LT minus 1 square. 2 will not take. 2 is a dimensionless constant. If you want to mention it, you can mention it. Dimensionless constant. So A is what? LT minus 2. What is S? It is L. Solve it out. It becomes minus 2 like this. It is L square T minus 2. It is L square T minus 2. So again dimensionally what we see, the relation is what? Correct. So in this way we can see number of examples where we find some physical relations and there's a consistency. Okay. So these are the applications. Say one of the example again I will give you of class 11th, which you will see, is that W is half mb square minus half mu square. Now this is work energy theorem, and this will come later on in work energy power. Work is change in kinetic energy. If you see, it is the change. So what is work? Force into displacement. So I am writing directly ml square T minus 2. Half we will not take. What is mass? M. Okay, what is velocity? LT minus 1 square. Again mass M. What is U? LT minus 1 square. Half is what? Dimensionless constant. Got it? So see here, ml square T minus 2. Again here, ml square T minus 2. And it is again ml square T minus 2. So we can say that dimensionally the relation is correct. Okay, so you can check the relation, that how this is W stands for what? Work energy theorem. So you see that this relation is dimensionally correct. So in this way you can get some question based on what this. Now the next application. Now second application is to derive the new relations, or to derive any formula, deducing relation among the physical quantity, to derive the new relations. We can say we can derive the expression, relation, formula, okay? And you know that it is only that if one know the dependency. That means if one is dependent on another of a physical quantity, I'm writing it why. Physical quantity on other quantities. So we will derive this also on another quantities. Okay, it can be of any type. So if one know the dependency of a physical quantity on the other quantity, we can derive the relation. How, for example, that the question comes that the time period, I think all of you know this time period of a simple pendulum, okay, depends on first length of the pendulum, second is, that is L, and second is acceleration due to gravity, okay, that is G. Now the question is, find expression for t time period. This is the question. So time period of a simple pendulum depends on length and g. You have to find out how to solve it. I will show you. See, time is dependent on two factors. So time is directly proportional. You'll write it like this, L and G. But though we know the relation, we'll find out it. And then the second step is that what do? You take the power of LA and GB. Any other, you will take the power C. Okay, say mass, M will be C. So this you have taken. Okay, because the proportionality has been taken out, so you will take some constant. K is a dimensionless constant. Okay, dimensionless constant. This is the technique. So you'll take K here. And then now writing the dimensional formula, then we'll write the dimensional formula for them. What is the dimensional formula for time? If you remember, it is m0 l0 t. What is for length? It is LA. What is for G? Gravity, LT minus 2. Got it? Now m0 l0 t, you know that it will be here what? See here, LA plus B and T minus 2B. Do you know this thing? Yes. Now these are the two things. And now what do? You equate the dimension. Equate the dimensions because LHS should be equal to RHS. Now equate what are the dimension? Power A plus B. What is here? 0. So A plus B can be 0. Right and left. What is minus 2B? Here it is 1. So minus 2B is 1. Can we get the value of B? Yes, minus half. And if you put it here, you will get A half. So you got it, the values of AB. And this is the first equation. Now put it in first. If you put it in first, what do you get? T, it is K, L to the power half and G to the power minus half. So ultimately, you got it, it is root L by G. And we know that even sometimes student they write proportional root L by G, it is also okay. It is also correct, it is also correct. And we know, I think all of you know, what is the time period of a simple pendulum? 2 pi root L by G. 2 pi is a constant. So we have to just check the expression of the dimension, how we calculate it. Do you know? So this is again repeating, T will be proportional to the values, and then you will write the dimensional formula, and then you know that you just replace it by their powers and you calculate the power and then you put it here. You will find out the expression. Yes, this is the way. So this is very simple. You have to go again. I am going to repeat another question based on this so that you will come to know. I am going to give you another relation. Say the question comes, the viscous force, okay, say the viscous force depends on the coefficient of viscosity. ठीक है, comma, radius of the body. ठीक है, and then v, velocity of the body. Okay, find the expression of viscous force. Find the expression of viscous force acting on body. So this will come in fluid, and you will see that how the viscous force acts on a body. So this is a type of a question. It will come in fluids. Now we know that if viscosity is given, viscosity sign will be eta and depends on R and depends on V. This is the first step. Then second is, you remember, K eta power A, R power B, V power C. Got it or not? and then replacing by dimensional formula. Okay, so I think all of you know what is F. MLT minus 2. K is dimensionless. What is eta? ML minus 1, T minus 1. Very important quantity eta. It is viscosity. What is RLB? What is VLT minus 1 to the power C? So make it like this, MLT minus 2, and then you organize it, M to the power A, L to the power minus A plus B plus C, and T to the power minus A minus C. See here, I have just written in this form. And then compare dimensions. You will compare dimensions or LHS, RHS. What is A here? A is 1. What is minus A plus B plus C? It is 1. What is minus A minus C? It is minus 2. If you see, it is minus 2. So you put it here, A1. So minus 1 minus C minus 2. I think C will be what? 1. If you see it here, you put, so C you will get 1. A is already 1. You put it here, then minus A minus 1 plus B plus 1 equal to what? 1. So ultimately B will also be 1. So all the values you got from these equations, one is this, one is this, and one is this. So this is the answer, and put it in first. This is what? Put in first. So what you get is K eta 1 R1 V1. And do you know, you can even write what I said like this also. So this is correct, this is also correct. Then final expression is this. So dimensionally correct, though the formula is 6 pi eta RB, but you have to write either in this or in this. This is the correct. You don't remember 6 pi, no problem, because you have to just deduce the relation. So I think again you got it. Again repeating, 3 quantities. This is the value you replace by dimensions. Then you compare their dimensions. Then you find out A, B, C. And finally, this is the answer. So can you deduce the relation? Yes, very easy. You can deduce the relation through this concept. So these are the two applications which are very important. One is to check the consistency of equation, and another is to derive the relation. Okay, and later on we will discuss other applications of dimension. Thank you, and regularly watch my videos.